recap on momentum. So momentum is equal to mass multiplied by velocity. It's how much damage something will do. Okay, small p for moment, m by v. Okay. Now, when we're doing these questions, we are going to have an initial velocity and a final velocity. Initial speed, final speed. And let's recap. Initial velocity is going to be u. Final velocity is going to be v. Okay, always, right? So the start experiment might be going 20 meters per second, u will be 20. At the end, you might be going at 40 meters per second, v is 40. Okay. Now we have a principle of conservation of momentum, and that says you add up all the momentums before a collision, and you add up all the momentums after a collision, and if you add up all the momentums before a collision, the total momentum before a collision, and you add up all the momentums after a collision, the total momentums after a collision, they're equal, as long as there's no external forces. The two external forces we were looking at, remember this from back when we were actually in the real world, are friction and gravity. Okay, but we're not worried about it today. Okay, we have a formula for that. Okay, we've two bodies are going to collide. Okay, and the formula you're given looks complicated. This one is easier than the other one, and you're going to get the hang of this now. Okay, m1u1, that's the first momentum of the first body. First body, we're going to put in 1 on it, and the initial velocity, plus m2u2, the mass of the second body, initial velocity of the second body, equals, m1v1 afterwards. It still has the same mass, new velocity, still has the same mass, new velocity. That's it. We're not going to be frightened by this. Okay, this is fine. Okay, only other thing we have to remember is if we have something going in a certain direction and we're saying that velocity is +7, if we're saying something else is going in the opposite direction, we say it's minus, so -3 or whatever. Okay, so that's the rule. Okay, and we must remember we're going to write our list on the left, we're going to write down the formula, we're going to fill in the formula. This is doable, lads. Okay, we're going to get there now. Okay, a lot of us are doing well on this. We want to all do well on it today. Okay, so let's take one example. Okay, so here we go. So look at it. Body A travels at 12 meters per second. It has a mass of 4 kilograms. It collides with a body B traveling the opposite direction with a speed of 4 meters per second. The second body has a mass of 2 kilograms. The first body's speed is 1 meter per second in the same direction after collision. Calculate the speed of the second body after collision. Now that sounds like a mouthful. We can manage it. Okay, so basically what you're saying is, okay, now we have one body traveling along at a certain speed. The other body's coming in the other direction. There's a head-on collision, and the first body continues in that direction. Okay, so we're going to see what velocity the second body has. So what we're going to do is we make our list on the left. Body A, okay, we're going to call this 1, and we're going to call body B 2. Travels at 12 meters per second. So that's the initial speed. That's before the collision. Okay, right, that's before the collision. So we have body A has an initial velocity, so u1, initial velocity of 12. Okay, it has a mass of 4, so body A has a mass of 4, so we're calling body A1, we could call it A if we liked. Okay, 4. It collides with body B traveling the opposite, this is crucial, opposite direction with a speed of 4 meters per second. So body B, initial velocity of the second body is the opposite direction, it's -4. Okay, -4. The second body has a mass of 2 kilograms, so m2 is 2 kilograms. Now after the collision, the first body's speed is 1 meter per second in the same direction after the collision. So v of the first body is 1 meter per second in the same direction, and we want v of the second body. A lot of work done there. Okay, and now we're going to write down the formula that's given to you. Okay, let's go through it. M1, so the first body, instead of M1, 4. U1, 12. Plus M2, 2. U2 minus 4. Okay, afterwards, M1 is still 4, and velocity is now 1. Plus M2 is still 2, and the velocity we don't know. Let's look, we'll tidy it up. 48 minus 8, so that's 40 equals 4 plus 2b. Suddenly we have a nice handy junior cert ordinary level linear equation. Okay, so we want to get v on its own, so 40 minus 4 equals 2v. So we get 36 equals 2v. Divide both by 2, we get v is equal to 18 meters per second. Okay, and basically that's plus 18, so basically the second body has rebounded, okay, at a much greater speed of 18 meters per second. That's it. You're going to try one of these now and you're going to send it up to me. You're going to do it now for the last bit of the class. Send the assignment in to me and we'll see what it looks like. Okay, very good.